Section 13, Radiation-Dominated Era, Part 1. It would seem reasonable to start the history of the expansion of the universe at the beginning, at the Big Bang. Some aspects of the expansion were simple then, others were extremely complicated. The scale factor grew as the square root of time, which is very rapidly for the first second after the Big Bang. From 10 to the minus 32 seconds to 1 second, 32 orders of magnitude of time, the scale factor increased by 16 orders of magnitude. In the 13.78 billion years after the first second, the scale factor has increased by 10 orders of magnitude. So expansion was very rapid in the early universe, but decelerating rapidly. The temperature was 13 billion Kelvin at 1 second, and fell as 1 over the square root of time. The radiation energy density and pressure fell very rapidly as 1 over the square of time. However, to place values on the scale factor, we need to connect it to the present, where we have observations of the universe. We need to work backward from today, where radiation is no longer dominant. We want to know the composition of the universe over time, so we need to work backward. The actual expression for the scale factor when dominated by radiation is this expression. The scale factor was about 2 times 10 to the minus 10th at 1 second after the Big Bang, and proportional to the square root of time for the first 6 years. The temperatures and densities in the early universe are so much different than what we see today that we should build our understanding backward in time. Additionally, the particle physics of the first second of high temperature, density, and pressure is complicated and unfamiliar to us, so we will work backward toward the Big Bang.